Hi guys, so Unit 2, Learning Target 1 is calculate the rate of change from a graph. Alright, so before we get into calculating rate of change and graphs and all that kind of stuff, I want to just talk about linear relationships. This unit's big picture is linear relationships. Now it's something that hopefully you've seen before. I would be certain almost all of you have heard that word linear before. So what I want you to do right away is just go ahead and jot that or write as much as you can about what you think a linear relationship is, your definition. So go ahead and pause the video there and write down your definition. Then we're going to get into our definition, and by no means is your definition wrong if it doesn't match up exactly with what I'm about to talk about, but we want to make sure that we have some common language that we talk about. First of all, some language that we are not necessarily going to use, and you probably won't use a lot, is the term recursive routine. And you can see here, your book uses the word recursive routine a lot. And a recursive routine is just like having, and you don't have to write this down, I'm just going to explain what a recursive routine is here. The book talks about having like a starting value. So if you start at 5 and add 2. So it has a starting value and a rule. So start at 5, add 2. Start at 18 minus 6. Start at 42, add 4 and minus 2x. Something like that. And then it just has like a pattern. So if we started at 5 and added 2, then our recursive routine would be 5, 7, 9, 11, 13, and so on. Okay, so that's a recursive routine. So your book's often going to ask you to write a recursive routine. It's just asking you about rate of change and starting value like we're going to talk about today. They just use different terminology, and we like the problems, so we wanted to keep those problems without confusing you with that definition. But a linear relationship in general, we'll go ahead and define that here quick. A linear relationship in general, we're going to say that it's a relationship that you can represent with a straight line. It's characterized by a constant rate of change. So I would also like you to write somewhere in there that it has something to do with an x and a y. When one variable changes, the other one changes at a constant rate, or the rate between the two variables, they go up not the same amount each time, but if this one goes up 1 and this one goes up 2, then for every time that this one goes up 1, this one's going to go up 2. That ratio, that rate, is always the same, and that's why we call it the constant rate of change, and I'm sure you've heard that term before now. So let's define it. The rate of change is going to have a ton of words, okay? We say slope, we say constant rate, we say rise over run, and then the variable for rate of change is m. So all these things mean the same thing. The slope is the rate that you're going up, okay, the rate that you're going down. It's the change in the y value in relation to the change in the x value. And we'll write that as a fraction eventually. We'll write things like the change in x, that triangle delta means change, over the change in y. We'll write things like rise over run. That's what that means. No, you don't spell run, R-U-N-E. That was a blonde moment. We'll write that, and hopefully you have some of an understanding about that, but one of our goals in algebra is to increase that understanding. And then the other part of a linear relationship is the starting value. The starting value, again, has many terms to go with it. It's the y-intercept. When we're talking about graphs, we talk about the y-intercept, and a lot of times in equations we talk about the y-intercept. It's the starting, it's like a startup cost if we're talking about like building a house, or it's the amount you get paid for just doing something, and then you get paid maybe more per time, or it's maybe like a cell phone plan costs $20 plus 10 cents a minute or something. Whatever you initially have or initially don't have, because these can be negative values too. On a graph, it's the y value, or on a graph, it's where the line crosses the x or the y-axis, so it's this point right here. And then on a table or in a situation, it's when it's the y value when x is 0. So when x is 0, then this is your startup cost. This is your y-intercept. This is your starting value. Okay? So those are just some beginning definitions to get us started with the unit. Let's move into an example. So we walk into an elevator in the basement of a building. Its control panel displays a 0 for the floor number. So we're on either the ground floor or the basement floor yet. We don't know yet. As you go up, the numbers increase one by one on the display, and the elevator rises 13 feet for each floor. The graph shows the floor numbers and their heights above the ground level. We're asked, what is the rate of change for this situation? Well, first of all, I want to look at the graph first. So what I'm seeing here is that my height is measured on the y-axis. My floor number is measured on the x-axis. So here, when I walked in, my elevator said I was at floor 0. So now, after looking at the graph, I'm going to say we were in the basement because it looks like we were in a negative value. So we were underground. If this is ground level, we were underground. So I'm going to say we were in the basement. And then as we're going to each next floor, we're running one floor at a time. That's the change in the x. What are we doing in the change of the y? Well, we can read from the story problem that we rise 13 feet. And if you look at the graph here, it looks like we go from maybe -4 to +9, something like that. So it looks like we're moving around 19 or 13 feet each time. If you look here, that looks like a little more than 10, a little more than 10, a little more than 10. So what is the rate of change for this situation? We can either write it as 13 over 1, because as we rise 13 feet, we're running one floor. Or obviously, all of you guys know that the rate is just 13. Okay, so 13 over 1 is just 13. What's the real world meaning of this rate of change? That just means that for every floor, we rise 13 feet. All right, and it's positive because we're going up. We're asked, how is the rate of change represented in the graph? Well, it just, between each value, between each dot, there's 13 feet of difference. There's 13 feet of difference there, there's 13 feet of difference there, 13 feet of difference there, and 13 feet of difference there. If you want to write that down in some form on your note sheet, that's fine. If you get that, then let's just move on. So before class, I'd like you to consider the following graph that shows students' distance from her next class. So time is our independent variable here. Distance from her next class is here. You're asked, what is the rate of change? What does it mean? And what is the starting value? See if you can stretch yourself a little bit more there and talk about the starting value and what that means in terms of the situation.